Welcome to the next lecture in the course Introduction to R Software. In the last couple of lectures, we have considered some statistical function and graphics, and usually we have concentrated basically on one variable. That means we have data only on one variable, that is something like height or say weight. Now in this lecture, we are going to consider a situation where we have data on say 2 or 3 variables, and we want to extract the information that is contained inside these data sets. In order to do it, we have two options. First, we try to have some information from the graphical procedures, and second option is that we try to get this information in some quantified form. For example, we had discussed earlier the interpretation and meaning of skewness and kurtosis, and then we quantified them using the coefficient of skewness and coefficient of kurtosis. So similar thing we would like to do with the 2 variates and 3 variates data. So in this lecture, we are going to concentrate only on the graphical procedures, and we would try to learn how to create various type of graphics when we have data on say 2 or 3 variables. And in the next lecture, we will discuss how to quantify them. What are the analytical tools which can help us in studying the relationship. So we start here in this lecture, and we are first going to consider the bivariate plots. Bivariate means there are 2 variables and we want to study what is the type of relationship which they are having. What do we mean by this thing? For example, if I try to take here say this sort of plot or a graphic which is like this, and here is my variable x and here y. Here I can see that this graph is indicating that the relationship between x and y is increasing. That means as the value of x increases, the value of y also increases. And similarly, if I say here that if the plot looks like this one, so I can see here that this relationship is not linear, but it has got some curve which is first increasing, then decreasing, and then finally increasing as x increases. Similarly, if I try to see here this type of relationship between x and y 2 variables, I can see that there is no relationship and possibly they are randomly distributed. So these type of information we can obtain from the bivariate plots. Here I am going to consider 2 variables, and in this example I have denoted them by x and y. So these bivariate plots, they provide the first hand visual information about the nature and degree of relationship between 2 variables. What do we mean by degree? For example, if I try to take here say 2 data sets on the same scale, say on x and y, suppose one is like this and another is like this. The scales on the x and y axis are the same. So you can see here that the degree of relationship is here higher. The values are very close to the line, but here the degree of linear relationship is lower than this one. So we are going to explore all these aspects, and you also have to keep in mind that these relationships can be linear or they can be non-linear also. So we try to take here some example, and through that example we will try to see how we can draw different types of curves. Right, okay. One popular simple good command in R to make such bivariate plot is plot, P-L-O-T, and obviously these are bivariate plots, so there have to be 2 data vectors, What do you mean by data vector? Suppose I take here two variables. Suppose one is here height and another variable is here weight. And suppose I take the person number here 1, I try to measure its height, suppose 154 centimeter, and weight suppose 60 kgs. And I try to take here person number here 2 and I try to measure his height say 170 centimeter and say weight 70 kg. So this is, I can denote, this is my here say variable x, which is height, and similarly I can denote say another variable weight is denoted by y. And this is the first observation. So this is like here x1 and this is the first observation on weight. So I can denote it by here y1. And similarly the height of the second person, which is 170 centimeter, this is the second observation on the height. So I can denote it by here x2, and the weight of the second person, which is 70 kg, can be denoted as y2, which is the second observation. So based on that we can have here two sets of data x1, x2, xn and say y1, y2, yn. And these values are going to be contained inside the data vector x and data vector here y. So these two x and y, they are denoting the two data vectors. Now I simply have to use here plot xy and this will give us a plot. Beside this plot command, there are some options which can be given inside the argument, and this is called here as a type. By controlling the type, I can generate different types of graphics. For example, I write here plot and inside the argument I write the two data vectors separated by comma, and then for the type I can choose here different types of options. Suppose if I choose say type equal to here p, then the graph will be coming in terms of points. And if I try to use here say here L, type equal to L, then the curve will be coming in terms of here lines. So you can see here that P is here actually point and this here L is denoting here this L for lines. And similarly if I need points and line both, then I have to use here the option both, and we use here the option B, which is the B of both. And similarly I can use here the option or say type C for the lines that are the part alone of only this here both, that is B. And similarly I can use another type here O, which is used for both, that means over plotted. And similarly I can use another type here S, this means say stair steps. So this S is coming over here and here this O is used over here. And similarly I can use something like a high density vertical lines by using the option here H, which is something like for histogram. So why not to take an example and try to explore that what does this type means and how do we obtain these type of plots. Beside this type command, there are some more options. For example, whenever you are trying to make a plot, you would try to control the values on the x axis, the label on the x axis, similarly the values and labels on the y axis, different types of colors. So there are different options. And some of the options I am mentioning here, that I can use here the option like here main, sub A, x lab A, y lab A, ASP, TSC, SP, and these have got different meanings. For example, when I want to have the title of my choice, then I can use here main. Then if I want to have a subtitle for the plot, I can use here the sub A. When I want to control the title for the x axis, then I can use the option x lab A. When I want to control the title on the y axis, I can use the option y lab A. And when I want to control the ratio of y and x variables, then I can use the command ASP, right. So why not to take an example and we try to implement all this option and see what do we really mean by these things. So in order to understand these plots, let me take here an example which has two data which are dependent. For example, we know that during summer when the temperature is high, the demand of water consumption also becomes higher. So, we know by our experience that as the temperature increases, that is the weather temperature increases, the demand of water also increases. So, what I have done, I have just taken artificial data, and this data is indicating that the demand of water in a particular city is collected on say 27 different days, and the weather temperature during day on these days is also collected. So, we have here data on say 27 days in summer, and all these 27 values are obtained for say daily water demand, that is in million liters, and the day temperature in say centigrades. For example, this first value here, this is 33710, and the first value and the temperature is 23. So, that is indicating that on the first day the temperature was 23 degrees centigrades, and on that day the consumption of water was 33710 million liters. And similarly, the second value in the water is 31666, and the second value in the temperature is 25. This means on the second day the temperature was 25 degrees, and on that day the water consumption was 31666 million liters. So, we have this type of data for say 27 days. Now, using this data I try to store them inside the R, and I have plotted different types of graphics. So, I am using here, see here, for the X I am using the water data, and for Y I am using the data on temperature, right. These are my two data vectors, and I use the command here plot xy, which is plot, and inside the argument you have to give the two variables separated by comma. So, first I will try to show you all the slides which are the outcomes of different option, and then I will try to repeat them on the R console. Okay. So, when I try to give the command here plot, inside the argument water and temp, which are indicating the data values on the water consumption and the temperature of the weather. You can see here you are getting here this type of curve. Here on this side you can see here it is automatically taking the labels as name of the variables water and here temp, and here you are trying to get here these values as the say small circle, very small circle, and you can get this type of plot. And yeah, this plot is indicating that there is a linear trend in this direction, and you can see here that the water consumption is say increasing with respect to here temperature. And if you want to rotate it, that you want to bring the temperature on the x axis and you want to bring the water on the y axis, you can plot here, plot say here temperature and water. Whatever you want you can do it. Well, I am not discussing here what is the right or wrong way, I am simply trying to show you how to create a graphic, right. Okay. Now, in the same data set water and temperature, if I use the option here L, this L is used for lines. You can see here I am getting this type of data set. You can see here this data set and the earlier data set, they are the similar data set, but what is happening that in the earlier data set these points have been joined together. So, this is a line plot. Similarly, I try to take another option where I want line and point both. So, I use the option here B, type is equal to here B, and I get here a plot which is indicating here points as well as here this lines. So, I will get here this type of plot. Similarly, suppose I want to make a plot in which the points are interconnected. So, what I would try to do here that I will use the option O, which is mean over plotted, and in this case you can see here all these points they are joined together. So, now in this plot we can see that we have here points and the lines are interconnecting them. So, they are over plotting them, that is why this is called as over plotted. Now, in the next thing, suppose I want to have the graphic in terms of say high density or say histogram. So, I use here option H, and I get here this vertical line. This is the first observation, this is the second observation, this is the third observation, and so on. Right. And similarly here, suppose I want these points as a stair steps. So I have to use the option here S, and as soon as I do so, I get here this type of, say, this curve. Right. So why not to plot it on the R console and try to see whether are we getting the similar outcome or not. So first I have to enter the data, which I already have done so. For example, here water is like this and temperature here is like this. And now first I would try to plot the same thing so that I can copy the same command so that you are confident that it's the same thing. For example, I can try here with plot water temperature. So you can see here is the curve, and I can reduce this window size also so that you can see it here more clearly. Right. And similarly, if you want to have here this a plot with here lines, so you can see here this command, how this command is going to change. You get here this type of curve. Now if I try to change here for B, you get here this type of curve where you have both lines and points. And similarly, if you want to change here the option to be here O, that is over plotted, you get this type of curve. And if you want to change it with, say, high density histogram lines, so it is like this. And similarly, if you want to change it with your, say, stair steps, so this is something like stair steps type of plot. Right. So you can see it is not difficult to draw such graphics, and now let us come back to our slides. Okay. Now after this, we try to play with these graphics, and I try to take several examples where I try to change the title or some other aspects of the graphic. So let us try to take the same example. You can see here one thing before I go further. You can see here that the title on the x axis here is water, and the title on the y axis here is temp, T-E-M-P. And suppose I want to make it more. So now we do like this. I use the same command here, plot between water and temperature, that is temp, but I am changing my titles on the x axis and the y axis. I want to give here daily water consumption on the x axis, and I want to give day temperature on the y axis. So I try to use here the options x lab and say y lab, and whatever title I want, that has to be given inside the bracket sign. This is the only thing which you have to keep in mind. And I also want to change the title of the curve. If you see in the earlier slide, there is no title here. Nowhere here, if you try to see, there is no title here. But now I want to have a title of the curve. So for that I use the option here main, and inside this double quotes I try to write down that what title I want, daily water consumption versus day temperature. Right. And when I try to do so, I get this type of curve. You can see here. Right. Here I have got the label daily water consumption, which is coming from here. Then here I am getting here daily temperature, which is coming from here Y lab, this is here, and this title, this is coming from here. So why not to do it on the R console? So you can see here at this moment we have the earlier curve on the screen, and now I am trying to write down the new command, and as soon as you try to say enter, you can see here these things are changing. Here you have, try to move with my cursor, try to look at my cursor. This is the title, and here on the y axis it is the new title, on the x axis there is new title. So this is how I can play with, say, this different things. Now there is another option which can create different types of a smooth curve, and for that we have a command say scatter dot say smooth. That means a scatter diagram has to be there and we want to join those points with a smooth line. So, this is the function scatter dot smooth, and inside the argument we have to give the data. For example, if I try to take the same data on water and temperature and I try to plot this scatter smooth, you can see here we get this type of curve. Right, here all these points are there, but beside them there is a line which is here, which is a smooth line passing through with most of the point or close to that those points. So, why not to try it here on the R console. So, you see here when as soon as I run you get this type of here curve, right. So, we come back to our slides and try to play with more. So, let us come back to our slide and try to explore some more options in this scatter smooth options. You see there are several options which are available with this scatter smooth function, right. Means I would say that you please try to go to the help menu and try to look into those details and try to see what more can be done. There are different options. For example, suppose if you want to change the color or means their position and everything. For example, here I am using something like L parse, which is equal to list, which is column, which is giving us the color red, and something lower value and say LWD and LTY. So, what are these things? It is difficult for you to remember each and everything, but whenever you are trying to play with the graphics, it is important that you try to go into the help menu and trying to see that there are so many options. For example, if you can see here there are so many options here, say span, degree, family, Y-lab, Y-lim, and there are many things, right. And depending on your need you try to use them. For example, here I wanted to change the color of the line and I wanted a dotted line. So, you can see here I am able to obtain with these commands. So, if you play more and you experiment more with such options, you can learn better than anybody else. Another option in this plot command is that suppose I want to make more than one plot together. Suppose for example, here I have two variables water and temperature. Think of a situation where I have got suppose three variables, say call them as say x, y and z, something like water, temperature, say humidity, right. Now, I would like to have a plot in which I can plot all the things together. So, there can be a plot something like plot between x and y, plot between y and z, and there can be another plot between x and z. So, one option is this, I try to plot them separately, or another option is that I can plot all those plots inside a same graphic. That can be achieved by matrix scatter plot, and for that we have a command pairs, and inside the arguments we have to specify the data vector. But remember one thing, when we are trying to specify the data vector, that has to be in the form of a vector. For example, means if I want to create a matrix scatter plot of the same data water and temperature, then I have to write water and temperature inside argument, and then I have to combine them together using the cbind function. Now, this becomes a vector quantity, and now I can say here pairs inside the argument write down this vector quantity, and as soon as I do so, you can see here I get here a outcome of this type. Well, here on this screen I am trying to take only two variables so that you can see clearly what is really happening. Means if I try to take 3 or 4 variables, the figure will become very congested and it will be very difficult for me to explain you what is really happening inside the figure. So, I would request you try to take 3 variables, 4 variables and practice with them. Here I am trying to take this example and I would like to explain you what is the meaning of different graphics. You can see here in this graphic, we have here 4 pictures 1, 2, 3 and here 4. So what's really happening, actually in the picture number 4, it is trying to take here water on the x axis and water on the y axis, so which has no meaning. So this is simply trying to say here this is water, and similarly in the picture number 4 they are trying to take temperature. But more important pictures are on the off diagonal sides, which are here and say here. So you can see here, this is here temperature, so this temperature comes over here, and on this axis this is here temperature, and here this is here water, so this water comes over here, and this is here water. So this is a graphic, that is the graphic number 2 is indicating a plot between water and temperature. This is a plot between water and temperature. Now we come to figure number 3. Here you can see here, first we have to find out what is happening on the x and y axis. So to know this thing, I will say here this temperature is coming over here. So on the y axis we have here temperature, and this water is coming from here on the x axis. So on the x axis we have here water. So again this is a picture between, say here, temperature and water. So yeah, means having a picture between water and temperature and water means the interpretation remains the same, only the graphic is reverted. So you can see here, if you try to compare this figure number 2 and figure number 3, you can see that all the points are just flipped, and this is how we try to make an interpretation in the matrix plot. Now if you want to make some more changes in the matrix plot, you can see here that in this matrix plot we have the title here water, and here it is the temperature, and suppose I want to change them. These options are also available, and now I can modify my this pairs function by using the option here labels, and inside the combined vector I write down the daily water demand and day temperature, which are the desirable labels which I want. And if I try to plot it here, you can get this type of picture, which is the same picture, but only these labels are now changed. So why not to experiment it on the R console itself, and we try to first create a matrix scatter plot. You can see here we have no matrix scatter plot. Now I try to copy, and as soon as I execute it, this gives me this type of matrix scatter plot. And now when I try to experiment with the second one, this is here like this, and now in this thing you will see that the names are changed, right. So you can see that it is not really difficult to do all these things. So here means up to now I have taken the example of 2-dimensional plot. Similarly we can also create 3-dimensional plot. 3-dimensional means there are 3 variables, and in order to make 3-dimensional plot in R, we have a special function which is called as scatter plot 3D, SCATTERPLOT 3D, and inside the argument we have to give different types of option depending on our need and requirement, and this will plot a 3-dimensional point cloud. But this option is not available in the base package. For that you have to download and install a package what is called as, say, scatter plot 3D. So using the command install.packages you can install this package, then you can upload this package using the library command. Then you need to set your working directory, do not forget it, and then you have to read the data. In order to show you here, I have considered a very small data set so that I can illustrate how you can create a 3-dimensional plot. So I try to take 3 variables here, say height, weight and age of only 5 persons, and then I have stored that data in, say, in this file data -age -height -weight.csv. Right. So I try to read this CSV file by this read.csv command, and I store them in a data vector 3D, and I try to store this data inside a variable called data 3D. So data 3D looks like this over here. Well, now I will not be showing you this thing on the R console, but I will request you that you please try yourself, then you will understand it more. I am simply giving you here the commands and the screenshots or the graphics which will come. Okay. So, now in case if I try to create this scatter plot 3D, then the variable name here is data 3D, but here you can see one special thing. I have to write down the data in this format, comma and 1:3, that means from 1 to 3rd column. There are various options which are available with this scatter plot 3D, and it is really very difficult for me to explain each and everything here. So, I would request you that you please take the help using the help scatter plot 3D and then try to look on the help menu. But my objective here is to show you that these things are possible. So, if you try to do so here, you can see here I get this type of 3-dimensional picture where these are the points which are indicating the 5 values. And here on say x axis we have here height in centimeters, in y axis we have here age, and on the z axis we have here weight. Okay. And similarly, in case if you want to change the angle of this 3-dimensional picture, that is also possible. You simply have to add one more option here, angle is equal to 120, and the angle of the figure will be rotated by 120 degrees. And similarly, there are several other options which I would like you to explore depending on your need. Whenever you need them, try to understand them and try to implement them. Some more functions for this 3-dimensional plot are say contour lines, dot charts, images, mosaic plot, perspective plot. So, here I am simply trying to give you here some examples of those functions, and whenever you need them you can just use them. Okay. Now, in the next few slides I simply want to show you that what other types of graphics are possible. I will not create them here, I will not discuss them here, but I simply want to inform you that these things are possible, and whenever you want to create them, please try to learn and do it. Okay, I already have given you the basics that how to understand and how to create graphics. For example, if you want to create here multiple bar plots, that is possible like this one, right. If you want to create here grouped box plots, that means more than one box plots inside the same plot. Means earlier in our example I had created 2 box plots separately, but here all the box plots are going to be computed simultaneously. Right. Now, I would like to stop here, and I have tried my best to give you a flavor for 2-dimensional plot and 3-dimensional plot. Now, the success depends on you, that unless and until you take some data sets and you try to execute these commands yourself, it will be difficult to learn. The more you practice, more you learn. So, you try to take some data set and practice them, and we will see you in the next lecture where we are going to discuss that how to quantify the information on bivariate data using the concept of say covariance and correlation. So, see you in the next lecture. Till then, goodbye.